But prefabrication, offsite construction suggests, and you all know this, that potentially we can overcome some of these challenges or dysfunctions in the construction industry. Number one, the site doesn't have to be different every single time. In fact, the majority of the work can happen in a single site, right? We also see that the program, yes, it is going to be different every single time, but the elements that are used to build that don't need to be necessarily different in each instance. And then finally, the labor that's used can be consistent from project to project, ensuring quality control and gaining efficiencies. This is a map from the Construction Industry Institute, which reiterates these points and states that in the manufacturing sector, you see value-added activities. Those are things that actually produce money or value to a project, are 62% of all activities. While in the construction sector, it's flipped, it's opposite, 57, almost 60% of all activities would be considered wasteful. They don't have any use. I might suggest the shipping back and forth of shop drawings between designers and fabricators is one of those wasteful activities. Really unnecessary again and again and again. The one on the left is a Toyota Scion. I don't know if that's how you pronounce it here, Toyota Scion. And on the right is a standard cold form steel framed up partition wall, non-load bearing, with sand attenuating material in the center and fire rating gypsum board on either side. This is about a 4 meter by 4 meter area wall. Over the life cycle of these two objects, they cost the same amount of money, right? Roughly $15,000 US. Need I say more? This is what we think of as prefabrication in the United States. We probably have similar prefabrication. This is 2 miles from my house in what's called a trailer village. 30% of our housing stock is this. It's the only affordable option in many respects we have. Now that off-site prefab is coming online, it's going to benefit us greatly. So, we've worked with industry through our center to try and demonstrate the quantifiable benefits of using off-site construction when compared with traditional site-built construction. This is to try and increase the uptake in the market share of off-site construction within the total construction industry. A couple of the projects I'll just talk about today. One is a project called Permanent Modular Construction, Process, Practice, and Performance. This documented 18 case studies internationally that used permanent modular construction, PMC. PMC in the US, as we call it, is anything that's built in a volumetric fashion, stacked one on top of another in order to make a traditional facility that's built to code. 17 projects in this case we ended up on. They range all over the planet and also in type. So we have in the western US, the eastern United States, central United States, Canada, Australia, Spain, and the UK. Multifamily projects, workforce housing, dormitories or student accommodation, healthcare, K through 12 education, and office space. Hotels and retail. Yes, Starbucks are now modular in the US. What we did is use a comparison method. That is, we tried to build these case studies that used PMC and compare them to case studies we could build or corollary projects we could build both that existed and we could augment with data to try and get as close as possible a like for like to be able to demonstrate how they actually perform. We did this through quantitative means and qualitative means. Quantitative, we collected data through literature that existed on those projects, a questionnaire in which we asked the architect, the fabricator, and the contractor, these three parties, and triangulated the information we got back from them. And then on the right, we then interviewed each of those parties as well. This is because some of them like to oversell the project, In addition, we noted that some did not have any information that others did. This is the best method we could come up with to try and get the data on this project. We got good information on general information, gross square feet, stories, module count, construction type, etc. Cost information, capital cost, design cost, construction cost, and modular costs. Project duration and schedule information. And then finally, what I would call labor initiatives, which are change orders, fatalities, reported incidents, and labor hours. Labor hours came out short. And we noted that this is a deficiency that would really benefit offsite construction if we could get a hold of it. Took this information and then asked from a quantitative perspective on the left and compared it or augmented it with qualitative interviews. Why did you use permanent modular? What were the successes? What were the challenges? And how did it perform? I'm not going to go into great detail, but these are the data sources we used to construct the site-built corollary projects that we compared them to. And I'll give you just 3 case study examples and then the total results of all the comparisons. Modules case study is built in Philadelphia. It's a student accommodation project. We found that compared to the site-built example we constructed, it was 26% more cost-effective and 44% faster build time. So here it is laid out, the data on the modules on the left and this compared project on the right. Again, we had to find real projects. Then we normalized all the data to Q1 2014, Washington, D.C. This is for vertical construction out of the ground, does not include real estate costs, site costs, and doesn't include development costs of the site. So some sites had a lot of water and needed to have dewatering on the site. Some sites have poor soils. It's difficult to compare head to head, so it's everything out of the ground. 9 months versus 16, 5 in wood versus 4 in wood, 80,000 square feet versus 55,000 square feet versus meters, right? What is it? 10 square feet is about a meter, a square meter. 12.7 million versus 11.7 million. And then we broke this down into costs per square foot, 158 versus 213. Another example is the Mercy Hospital. This is in Joplin, Missouri, following the big tornado there, and they had to put up a hospital very quickly. So they went to a modular solution. 30% more cost-effective and 60% faster build time. Compare head-to-head, 8 versus 9 versus 20 months, 2 stories in steel versus 3 stories in steel, 150,000 square feet versus 190K, 35 million to 63 million, and 235 to 336. The hospital personnel and administrators are very happy. We got to interview them as well. STEM school, located up in Tacoma, Washington, near Seattle, 21% more cost-effective and 29% faster build time. 12 months versus 17, 2 stories versus 4, 63,000, 73,000. 15.6, 22.8, and 247 per square foot versus 312 per square foot. So some of the results on the cost, you can see not all the case studies we collected in modular had corollaries, or we couldn't construct them. And so these are the ones that we felt were strong, and we could feasibly say this is an effective case study comparison. So we ended with about 7 or 8, and the least cost-effective was negative 74%. That's because the modular project had a lot of tech in it. That company has come back, who built that and is not very happy with us. We're trying to edit that data accordingly. The most effective was 40%, and the average is about 11 across all those case studies. 11% more cost-effective. Schedule. We found across these cases that these were the ones that we could actually compare. Least effective, 25% better, so still better, not in the negative. 60% is the most, and 42% average across those cases. We also collected that labor data. We found that in change orders, there were 5.63 change orders on average per project. It's quite a bit less than I'm used to, but we can't find corollary data on what is the standard in construction. It doesn't exist. And now we're trying to mine to see if we can find that. Reported incidents total across all the cases was 2 in any injury, and there were 0 fatalities. Labor hours were unreported. Then we collected this qualitative data. Why was it chosen? Cost and schedule, the 2 things that we were measuring, which is beneficial. Software, 62% of the projects were using AutoCAD primarily, 23% in Revit, Autodesk Revit, and other 15%. Some of the challenges: permitting and transportation, schedule overruns, and the lessons learned: early engagement of the fabricator. Design build contract is much better than something that goes to tender, right, and bidding, because those inherently, as we know, have computational formats. So those who use design build have much more success than those that did not. And then a high recommendation by team members was design phase modular research by the design team. The design teams that had experience in it or went out and visited the fabricator and used them in co-design or in design assist had much greater success in these projects. We did the same thing with solid timber, what we call solid timber or mass timber. It's becoming known internationally. We took 17 case studies, collected data on those. I'm not going to go through a few case studies with you today, but just to say that these are all available online for free. This is through Rethink Wood, which is much like Wood Solutions here. And then the permanent modular report is available at modular.org, which is our trade association corollary to PrefabAUS. Those are free and available to anyone that would like to download. I did include some cases there. Bridgeport House, 7% more cost effective. This is in the UK in Hackney, and 25% faster build time. So comparison, 12 months versus 16, 8 stories versus 4, 45,000 versus 55,000, 9 million versus 11, $198 a square foot versus 213. Across all of these cases, I mentioned costs at the top, schedules at the bottom, was an average of 11% better on cost effectiveness and 20% better on schedule. Some of the lessons learned or the qualitative information we got on these mass timber projects: positive speed, weather avoidance, carbon reduction, remote locations, labor costs, weight, precision, and safety. And then labor, on the negative side, labor skills takes a while for training and upskilling. Research is needed, much research. Logistics and handling, pre-planning. Acoustics is a problem with mass timber, as many of you know, and designing and detailing for that. Codes and permits and component.
It's Karen Manley from Queensland University of Technology. Thank you for that really interesting presentation. It's great to see some data about prefabrication in comparison to traditional builds. And it's great to see all the data freely available as well online. Probably this is mostly for an offline discussion, but I'm interested in how you generated those pairwise comparisons. You talked about like-for-like comparison. It's one of the most difficult things to generate that kind of methodology. I'm just wondering if you could say a bit more about how you located the comparison case study, the traditional comparison case study. Was that an existing project, and what were the tolerances for the likeness between the prefab and the traditional?
Everyone hear me? I like this. No, it's not still on. So yes, it's very difficult to do. And in the report at the end, we talk about an idealized model, which is we've approached Marriott hotels. They build these 4-story wood frame and steel projects, and we're in the process of trying to, Gurdon, who's a modular builder in Idaho just north of us, now builds most of Marriott's 4-story wood projects in modular. So these are all modular now. And we're in the process of trying to do one site built and one modular using the same on-site labor, and that would hopefully become much closer. To answer your question, however, we partnered with a cost consultancy company, very big one in Washington, D.C. called Cummings Corp. Look them up. and they have a massive database of projects they have worked on, all sorts of building types. We targeted them because we knew that they had experience across a myriad of building types and had a great database. So they used that to try and then located one project that they thought was close, and then they augmented that data with all the other data on the other projects to try to find some normalcy. It's not ideal, but it's the best we could do in that particular scenario.
I guess the sample bias is, it's good you acknowledge it, because obviously in terms of prefab, you're drawing the people with the best possible outcomes. But I guess you can position it as best case examples of what's achievable.
That's exactly right. And so we don't claim that this is characteristic value or statistically significant. We claim these are case studies. Case studies.
No, once again, congratulations. It's great to see the data.
Can I just ask a question? You talked about the difficulty of getting contractors to share data. I mean, that's the biggest issue we have here, is that the industry is measurement resistant, possibly because they think that they've got some intel that nobody else has got, but they all change people every other week. So they share the information irrespective. So how are we going to break through and start to get what I would call a pre-competitive knowledge base for the industry for this subject?
Open source prefab, yeah. That's a great question. I don't have an answer. All I would say is we have tried in the projects we've worked on, R&D projects, to protect IP in our projects. I've come to the conclusion after working on this for 15 years in firms and at the university, there is very little IP in this industry. Very little. And I would argue that I think we need to open that up. Unless you have something like a steel connection that's very valuable, which I've seen people make money on a seismic connection or something like that. But other than that, there's very little that's patentable. In fact, you can duplicate most of what's in the construction industry. So I would argue, that's why we talk about these reports. We leave them open to people. We talk about our products. We leave it open to people because I think that if someone really wanted to duplicate it, they could, and they should. We have, again, I just say we have very little IP in this industry compared to other industries. Yeah. And in order to have open sharing, I think that's the target. That's where we should be in order to innovate, try to move this industry forward. Share best practices back and forth openly. That's my opinion.
I have a question. Priyanka is from ITAC Center. It's a very interesting presentation, and thank you for sharing that US experience and very interesting data there. It's useful for Australia as well. Just a question on to be a real modular building or system, foundations, you need to cover the foundations. I haven't seen any building yet, like no modular foundations or any smart ways of doing the foundations. But any experience from US? Are there any people working on the foundation side as well? Because at the moment it's all on site done and then you bring back the modules. So it's not really totally modular. Of course, we are moving towards that. But any experience in the US that any research being done or any smart systems being developed in the foundations?
One, two-story helical foundations are being used quite readily in the US.
But medium rise as well.
Yeah. And then precast, of course, for mid-rise. But for high-rise, no, I don't think there is a solution. Nothing that I know people are working on. Good question. But the issue, right, is the connection between the tolerances in the factory and the site work, and that's a big problem we're having in the industry. Is as we get concrete contractors on board in learning about this industry, there's a learning curve, and inevitably the first two projects really go south because they just don't get that foundation right. And then solutions to it are shim, or somehow adjust that foundation. I think that's a big gap in the research and development that needs to occur.
Do we have one last question? Oh, we have two. Okay.
It used a standard post and rail construction for the typical system. Just wondering, with the glue-free product, is it possible to use them frame-free? Do they lend themselves to that sort of use?
When you say frame-free, could you explain what you mean?
To have them as being structurally strong within themselves, not need an external frame as was used in the past.
The bathhouse, majority of that is actually bearing wall. The wall is the bearing wall. Yeah. You only saw a few beams when the portico was coming out. That was supported by that. But the roof structure was all a solid plank. Yeah, I had no framing.
Chris Barnett from ITAC. I was just wondering, the prime drivers for the physically connected cross-laminated timber. Just wondering, is the cost, toxicity, why?
Yeah, it's a good question. So,
and on a second,
please.
What's the window of opportunity to get out the bark legal affected trees before it affects it?
Great question. So, when we started doing this, the Forest Service came forward and said, look, we have no use for these trees, and there were all sorts of grants and opportunities saying, how can we get a higher value use out of Forest Service lands that have these trees on them? They're a fire hazard, or they die and they're even more of a fire hazard. Can we slow down the carbon cycle by grabbing those trees and using something with them? So people are doing flooring, people are doing little benches in parks, right? Kind of anecdotal stuff. So this is trying to develop a solution that could actually use it on a larger scale. The pure motivation was, how do you use beetle kill pine? And that was where we were going. Secondary, the projects that have used it are all how I would call hyper-green projects. So they're projects that are not only concerned about the performance, they're also concerned about the embodied energy of the products going into the building. So the fabricator we're working with is known as kind of a granola builder, right? Although they build large structures too, and lodges up in Park City, they're very much committed to that. So those green strategies were really motivation. It has a cost premium right now, about 15% higher than site-built construction, but it's for a certain demographic and type of project. So.
Thank you, Ryan.
Thank you.
Ryan will also be a part of our industry